Hello and welcome to Theralase Technologies Class 3B versus Class 4 lasers. My name is Greg Bush, and just a little bit of housekeeping first. Welcome to the webinar, obviously, first, but if you have any questions anytime during the webinar, you can type the questions into the sidebar. Questions will be addressed during Q&A, and if we don't have time to get to all the questions, we will then respond to you via email. Okay. First off, a little bit about low-level laser therapy. It's probably one of the fastest growing fields in medicine, recognized by every major industrialized nation in the world, offering painless, non-invasive, and highly effective drug-free solutions. Now, it's often the only solution that is available to highly trained practitioners. I've seen situations where a doctor will have a pain clinic, and quite frankly, after all the cortisone shots and after all the side effects of taking major drugs, this is a way of alleviating a lot of inflammation and pain that works. And we've had many, many medical doctors who are now buying lasers. But unfortunately still, it's yet to achieve the recognition by the medical community due to the confusion in the marketplace. I think the reason is it's such a fragmented industry. There's a lot of poorly designed clinical studies in the published literature. These scientific studies and poorly designed clinical studies do more harm than good for low-level light laser therapy, as a large number of patients could substantially benefit from this modern miracle. And they're denied the service basically because a lot of practitioners are just not aware of it or willing to have a look at it. Now there's a lot of literature, and I've pored over a lot of it recently, pertaining to the direct photoacceptor of the light-absorbing chromophore of near-infrared light. A lot of manufacturers' marketing materials are particularly rich with assumptions about prime molecular photoacceptors and mechanisms of the light in the 800 to 880 range. However, the clinical literature shows no strong evidence that the cytoxachrome C oxidase is strong absorption in this range. So therefore, although the photobiological effects in the 800 to 880 nanometer light range are ascribed to light absorption by the mitochondria cytochrome C oxide, the low absorbance of this region makes a lot of scientists question it. Just want to run through what the FDA laser classifications are. Class 1, it's inherently safe. It's the type of laser that's used in CD players and laser printers. Class 2, it has output power up to 1 milliwatt. This class includes lasers that emit visible light. A lot of the laser pointers that you see are in this particular class. Class 3A, output does not exceed 5 milliwatts. Beam power density may not exceed 2.5 milliwatts per square centimeter if the device is labeled with a caution warning. Otherwise, a danger warning label has to be on that particular product. A lot of laser sights for firearms and laser pointers are also in this particular category. Class 3B are lasers that may cause damage if the beam enters the eye, and this generally applies to laser powered in the 5 to 500 milliwatt range. Therapeutic medical lasers are in this particular category. And you'll notice if you have a 3B laser that is used for therapeutic purposes, both the practitioner and the patient must wear glasses. Then we have Class 4. Lasers have output powers more than 500 milliwatts and may harm severe permanent damage to eyes or skin. Most industrial, scientific, military, and medical lasers are in this particular category. And of course, safety goggles must be worn in this one. A little bit about Class 3B versus Class 4 lasers. There's a lot of false information in the public domain regarding the effectiveness and cellular mechanisms activated during Class 4 light irradiation. Many Class 4 laser manufacturers are unintentionally misleading healthcare practitioners into believing that higher power and longer near-infrared wavelengths equate to deeper tissue penetration and better clinical efficacy. Well, nothing could be further from the truth. Particularly disturbing are claims made by manufacturers of some Class 4 lasers emitting in these 808, 880, 970, and 980 nanometer wavelengths. Unfortunately, all these claims do not have standing in the clinical and scientific journals to support their claims, and I've pored over virtually hundreds, and there have been very, very few, if any, double-blind studies in this area. The clinical and scientific facts are clear that because the very high absorption of laser light by water at wavelengths greater than 950 nanometers, 99% of the energy produced at this wavelength or above is absorbed before penetrating the dermis of the skin, leading to high risk of thermal damage and low depth of penetration. A Class 4 laser typically has higher incident power and larger treatment area, but the depth of penetration is superficial and is restricted to a few hundred microns at best, basically just the top layer of the skin. Once the thermal effects of tissue have been exceeded, tissue damage is imminent, and I'll show you a little bit later on what some of that damage looks like. Certain manufacturers use limited knowledge of their customers to claim the Class 4 laser has greater efficacy than Class 3B laser, and as I said earlier, this is really unsubstantiated. Treatment with laser therapy is not based on heat development, but on photochemical and photobiological effects in cells and tissues. There is a therapeutic optical response window between 600 and 950 nanometers and a biphasic dose response curve governed by the Arndt-Schultz Law, within which the positive bioregulatory effects occur. What we have here is an example of the therapeutic window. We have the hemoglobin, and you can see from the percent absorption, and along the bottom axis we have the wavelength. There is a therapeutic window that is approximately 632.8 nanometers up to just under 1,000 nanometers. And if you get involved in wavelengths higher than that, you will find that there will be some thermal heating. The water content will actually start to heat. This is what creates that feeling on some Class 4 lasers. We also have the Arndt-Schultz Law, basically stating that the biological effect, you can see in the very center of the slide, the response curve, when you add a lot more power, the amount of stimulating of the wound healing actually lowers. It's actually inhibited by a lot more power. It's one of the analogies that I have heard is that it's like having a plant, and you have, say, a glass of water, and you can pour the water in very, very slowly, and then the plant would then be satisfied. Or you can dump it in which case you'll often not get the same response. You'll have the nutrients leave the actual plant itself. Talk a little bit more about Class 3B versus Class 4. The use of Class 4 lasers have a high potential of delivering non-optical treatment doses of energy due to their lack of penetration and excessive exposure, thus presenting a greater risk of burning patients, particularly patients with dark hair follicles. Class 4 lasers for phototherapy is not new and it's not innovative, as such lasers have been in the market for many years and have been approved strictly for surgical applications such as general surgery and tissue ablation for port and wine stains, spider veins, just advertising the advantage of the Class 4, that it is a Class 4 laser, and hence it's a better instrument than a Class B, since the number happens to be higher. That's what it's often marketed as. Lasers with output powers exceeding 500 milliwatts are unnecessarily strong, and they are dangerous to conducting low-level light laser therapy treatments. Here's some examples of skin damage using a class 4 laser, and you can see we have a situation where the skin has bubbled out and just created burns, like a really severe sunburn, which then has to be treated as well. A little bit about our laser, the Theralase TLC-1000. It's approved by Health Canada, FDA, European Union. It's approved as a Class 3B Superpulsed therapeutic medical laser device. The advanced low-level laser therapy proprietary technology encompasses a very potent and complementary bioregulatory mechanism achieved using visible red light at 660 nanometers and near-infrared superpulsed at 905 wavelength. The Theralase Superpulsed laser has a distinction of being one of the fastest in the world. We deliver pulses at 200 billionth of a second, producing average powers of 100 milliwatts and a peak power of 50,000 milliwatts per diode. This unique parameter results in a high concentration of light energy or photon density at the tissue depth versus any other known competitive technology, but more importantly, without the risk of burning tissue. Our superpulsed laser system can penetrate up to 4 inches, and I'll show you a chart for that, to promote cellular regeneration at the source of the injury, and is the only laser on the market known to activate all 3 cellular pathways: the ATP, the iNOS, and the sodium pump. And basically, what these do is that they actually take care of, they accelerate healing. That's what the ATP does. The nitric oxide reduces inflammation, and the lipid absorbent pathway decreases pain. And so, and we've had fantastic results. We've also got studies that show the actual benefit of this, not done by us, but by third parties, universities, basically in double-blind studies. So I'll just go ahead and show you a chart of a superpulse versus a continuous wave laser. As you see on the left-hand side, we have a 905 nanometer LED laser, and it has a penetration of approximately a ½ inch. You then have a continuous wave laser at 905, and it gives you penetration of approximately 1 inch. What Theralase has done is that we have a 660 nanometer continuous wave laser to get that ½ inch penetration for surface wounds and surface inflammation. But our 905 nanometer superpulsed laser actually has penetration of up to 4 inches, and so it's an exciting product that works. What I've done is I've included a bibliography to, justifying all the statements that I have made that I'd be happy to pass on. We will give a copy of all the slides that I happen to have, and you will then be able to access, go to the internet, put it into the search bar, and you'll be able to get the actual study that has been done. One of the things that I wanted to point out was we have a white paper. It's about a 44-page white paper that's called Understanding the Mechanisms of Low-Level Light Therapy. And it's a free white paper, and it's available on our website, www.theralase.com. We felt that since the industry is so fragmented, we wanted to really have a document that all companies could actually look at. And I'll just read this from this briefly. Low-level laser therapy is a rapidly growing modality used in rehabilitation and physical therapy. A number of safe and beneficial therapeutic effects of low-level light therapy have been reported in numerous clinical conditions. However, despite many reports of positive findings from experiments conducted in vitro, in animal models, and in randomized controlled clinical trials worldwide, the use of this is scientific grounded, it's non-invasive, non-inflammatory, and regulatory modality has yet to find mainstream adoption by medical doctors. Now, we developed this 44-page white paper, and I think you'll find it very beneficial. We wanted to introduce the unfamiliar reader, someone with some medical background, to contemporary concept of low-level light therapy and its pathophysiological significance. We wanted to revolve the role of the mitochondria pathway in the mechanisms of low-level light therapy. We wanted to also provide necessary practical guidance based on scientific and clinical experience. We were also hoping that this white paper could be a basis for a lot of other manufacturers in their research and development. I think we all have to band together and come up with a solution which is reasonable to all companies. We wanted to help healthcare practitioners choose and use an adequate light therapy device, be either ours or another major manufacturer. And also we wanted to outline the prospects of low light level therapy as an avenue to treat chronic inflammation and pain and to aid in the effectual clinical practice. Included in this white paper, we have over 102 clinical studies, many of them double-blind studies, not written by Theralase, but within the scientific community. So that's what we have done, and I'd be happy to accept any questions. We already have received some that I have in front of me. I just took it off. One of the questions I have is, have there been studies done on companion animals and also horses? Well, to my knowledge, there have not been any double-blind studies in this area. We currently have a major university veterinary school conducting an equine double-blind study on wound healing, though. The results to date have been really encouraging and will be available by the end of the year, which we would then publish. We'll probably do a presentation at an international conference as well as publish it. A similar study is underway at another university veterinary school for companion animals where they are examining knee pain. Interesting enough, too, we are finding that there's interest in having laser therapy before an operation and also post-operation. It's very exciting, and it seems to help in the rehab. It's much quicker. Another question I have here is, how do I compute the dosage for a laser treatment? Well, since laser energy is absorbed by water, hemoglobin, and melanin, different people require different dosages, and so that the target tissue of interest obtains the desired energy density. The depth of this target will also play a major part in the decision. Since light energy is absorbed by other tissues that lie between the target tissue and the skin surface, one should increase the dose to obtain the desired dosage at a target site. In order to biostimulate the tissue, light must reach the target in a sufficient dose, otherwise biostimulation simply will not occur. Now, Theralase and most other major manufacturers give you a protocol manual and give you great guidance in terms of the amount of power needed, and we encourage you to use those. Someone here has asked from California, what is photon dosage? Oh, maybe I didn't explain that properly at the beginning. Photon dosage is generally defined as the amount of light at tissue depth determined by the amount of light delivered at the tissue surface. And it's affected both by the amount of power used and by the amount of time you are using it on the particular patient. Here's a simple question. I could even answer this one. What is the difference between normal light and laser light? Well, the major difference between laser light and normal light is the laser beam's ability to travel long distances without being dispersed. This is known as the coherence and enables the laser to focus its power within a small circumference. So you can actually target where you want it to go. Pulsated laser light has been shown to have a strong therapeutic effect on cells and muscle tissue. Our laser, the Theralase cold laser, for instance, doesn't produce heat or cut organic tissues at all, like some Class 4 industrial lasers or surgical lasers do. Instead, it pulses a focused or culminated light beam at body tissue, bone, skin, muscle, etc., which in turn has profound beneficial effects on the functioning of the human cells and the building blocks of the body. Here's a question that I know that our scientists often get. How does cold laser therapy help the treatment of rheumatoid arthritis? This comes from Detroit, Michigan. Rheumatoid arthritis is an autoimmune disorder, and so it's a little bit different than other types of uses for laser therapy, which attacks the joints, causes swelling and tissue damage. Rheumatoid arthritis is often different than non-inflammatory problems of the joints and often mistaken for osteoarthritis, which is inflammation caused by wear and tear on the joints. Cold laser therapy works by reducing the pain and inflammation caused by rheumatoid arthritis. The initial treatment schedule can depend on the severity of the condition and the length of the onset. Although the average patient receives about 2 to 3 treatments a week for a duration of about 10 to 20 treatments. Since it's an autoimmune disorder and it is non-curable, in order to maintain quality of life, a patient is often placed on a maintenance program of 1 or 2 treatments per month, thereby reducing the pain, the inflammation, and the increased range of motion. One question I have here is, this is from Chicago. What is photon dosage at tissue depth? Why is it photon dosage at tissue depth important? To provide a better treatment outcome, a practitioner needs to maximize the amount of photon light at the tissue surface by increasing the power of the laser at the time of the treatment. The limiting factor with laser is the amount of light that tissue can absorb non-thermally. That's really critical, non-thermally. This is known as the maximized permissible exposure. They often call it the MPE. To date, a superpulsed laser flickering on and off delivers the most amount of photonic energy without exceeding the MPE. And I have one of those questions so far from Toronto, Ontario. How deep into tissue can a laser penetrate? Well, it really depends if it's superpulsed or not. The depth of penetration of laser light depends on many parameters, such as the laser's wavelength, the power, the type of device driver. Is it a pulse? I should make a differentiation. A pulsed laser and a superpulsed laser are actually different. A pulsed laser is really just a laser light that has been gated. So it's on and off, on and off, on and off kind of thing. Continuous wave is obviously, but a superpulsed laser, as I had mentioned earlier, would actually, it's on and off, but it's to 200 billionth of a second. And that's I would consider that to be the best technique to actually use. The higher the wavelength, typically the deeper the penetration. However, with wavelengths greater than 950 nanometers, the water in the tissue absorbs light, and the depth of penetration is drastically reduced. Devices which have superpulse have better penetration versus continuous wave devices because they have the greater peak power densities for superior photon concentration at depth that you are searching for. Right now, I see there's more questions coming in, but I don't have them yet. Any questions we haven't gotten to, I will be happy to answer them. Also, after the seminar is over, you will be given an opportunity to get these slides for you. We will also be broadcasting it. It'll be on our website with a full audio and visual. But if you needed to get these slides right away, you can leave your email, and I'll make sure that you do get a copy here. It's one other question here has just come in. Are you saying that class 4 lasers will not work on MSK conditions at all, or are they just no more effective? No, I'm saying that the class 4 lasers will work, but they will work better using a class 3B laser. The added power does not have any kind of beneficial effect, and so in this case a class 3B laser would be the preferred laser to actually use. If there's any questions we haven't gotten to, we will answer them. I also want to say one more time, I want to encourage you to get our free white paper from our website, www.theralase.com. Go to the practitioner banner and click on white papers, and you'll be able to then get it then. And I think it would be very, very beneficial. I don't know if there's any more questions I can't see right now. I'm sure more will be coming in. And what I can say is that this has been a really challenging topic because, as I said, there's so much information published by every laser manufacturer, all claim to be the very, very best. We at Theralase believe that it's imperative to have proper scientific data, more often done by third parties of which we have no influence except by giving a laser for them to basically use. And we have basically partnered with a lot of universities to do this. You can, as I said, you can go to our website and get a copy of it. I think it'll be beneficial, not just for people using it, but also for manufacturers. We would like to start to work with other people to come up with standards that everybody understand. And I think that's the route that we are going to go. So I don't see there's any more questions currently. But if you want to hang on and ask some more questions, we'll be happy to get to them. And at this point in time, I am going to basically sign off on this. And as I said, if there's any other questions, please send them in, and we will answer them. Once again, thank you for your time, and we would love to be sort of the go-to company if you have any kind of questions that we'd be happy to answer about 3B lasers, as well as what we know of class 4 lasers. We've done a lot of research, and we look forward to working with our practitioners out there to the benefit of their patients. Once again, thank you. My name is Greg Bush, and thank you for joining us on this particular webinar. We have another one coming up next month that I think you'll find very interesting as well. Thank you.